Okay, so in this course, I'm going to expect you to be able to take the derivative of certain functions. So, as discussed in the last video, taking the derivative means finding the gradient. Now, mathematically, it's a bit of a trick trying to do this. I'm not going to expect you to be a master of this straight away, but what I am going to expect you to be able to do is to look up a table. So, like I've got here, so we can actually forget about the right-hand column of this table for a minute, but either of these tables, so this one on the right hand side or this one on the left hand side, I expect you to be able to look up a table like that, a table of gradients or a table of derivatives, and be able to find the function that you need to answer a problem. When you study more and more maths at school, you'll get the chance to learn how to differentiate these in general, and you'll get to either memorize these rules or learn how to derive them for yourself. So in this course, I'm more interested in your ability to use the calculus to solve physics problems than your ability to actually solve differentials. So, one key relationship that we have in physics, so far we've been talking about the velocity being the displacement over time. This is only for average velocity. If we want to know what's the actual velocity in an instant in time, the formula that we should actually be using isn't this. Instead, the velocity is equal to the differential of position with time. Similarly, the acceleration is the differential of the velocity with time. So let's do an example. Let's suppose that we had somebody who was approaching a traffic light. So they slow down gradually and come to a stop, and then the traffic light turns green and they start to speed up again. The position over time might look a bit like a cubic function. So let's just try this one here. So their position equal to t cubed. So in this case, if we want to find their velocity, what we need to do is we need to differentiate this function, because the differential of position with time is the velocity. So the velocity is dx dt, and in this case, this is the differential of t cubed with respect to t. Now please note, when we use this notation of dx dt, d is not a variable. You cannot cancel out the d. Instead, it's just a notation that means we're taking the differential of x with respect to t. Now, this problem here, t cubed, is one that we actually already know how to solve, because we know the differential for a polynomial is given by this formula. So, in this particular case, our variable is t rather than x, but the formula is still the same. So what we do is we take that power, that n, which in our case is 3, and we bring that down the front. So we have 3, and then we reduce the power by 1, so it becomes n minus 1, so it would be t squared. So if we have a look at what does the velocity over time look like in this problem, it looks something like this. It will be a parabola, given by 3t squared. And this makes sense. Originally, as the person's approaching the traffic light, their velocity is high, but they slow down until they suddenly stop, then they start to speed up again. So that's exactly what we'd predict. Now, if we want to find the acceleration in this case, we're going to take the differential of the velocity with respect to time. So in this case, the velocity is 3t squared. So we bring that 2 down the front, and 2 times 3 is equal to 6. And then we reduce the power again, so it would be 6t. So in this case, our acceleration would look something like this. It would be a straight line. And that makes sense. Originally, we have negative acceleration, and then, once you got past the traffic light, you have positive acceleration, and you start to speed up again. Now, the only thing that might be a little bit confusing here is it looks like I have negative time. Now, that just means that I've chosen time equals 0 to be the point where that traffic light turned green and I started to speed up again. And times before that have negative values. I could have set my time equals 0 to a different time. It doesn't really matter. Then all of my values would be positive. So this is how we can apply differential calculus to help us solve kinematics problems.